Hello friends, good morning to you all. I am Dr. Ranjit Dhunde. Welcome back to the lecture series on the topic complex number. In today's lecture, we will discuss logarithm of a complex number. Now let z is equal to x plus I times y. This is the given complex number. Now we expressing this complex number in terms of polar form. So this is equal to r times e to the power I theta, where this r is equal to modulus of z means r is equal to root x square plus y square, and this theta be the argument of z. This is equal to tan inverse y by x. Now we know that e to the power I 2n pi, this is equal to cos 2n pi plus I sin 2n pi, and this is equal to 1. Therefore, we expressing this polar form in general polar form. So therefore, this z is equal to r times e to the power I theta times e to the power I 2n pi, where this n is equal to 0 or positive integer or negative integer. 0 plus minus 1 plus minus 2 and so on. Now taking natural logarithm on both sides. Therefore, natural logarithm of z means log z to the base e is equal to log of this r times e to the power I theta times e to the power I times 2n pi. Now by using the logarithmic rule, the log of r times e to the power I theta times e to the power I 2n pi, answer is log r plus log of e to the power I theta plus log of e to the power I times 2n pi. Now this is equal to log r plus log of e to the power I theta, answer is I theta, plus log of e to the power I times 2n pi, answer is I times 2n pi. Therefore, this log z, now z be the x plus iy, is equal to log of r. Now this r be the root x square plus y square plus I, this theta be the argument of z means tan inverse y by x plus I times 2n pi. Now this is called the general value of log of x plus iy, and this is multi-valued function because by using different values of n we get the different values of log of x plus iy. Now general value of log of x plus iy is denoted by capital letter L o g of x plus iy. This is equal to log of root x square plus y square plus I times tan inverse y by x plus I times 2n pi. Now by taking this n equal to 0, we get the principal value of log of x plus iy, and principal value is denoted by log of x plus iy. So we use here small letter L is equal to log of root x square plus y square plus I times tan inverse y by x. So this is called the principal value of log of x plus iy. Now let us solve one problem based on the logarithmic function. Now example 1. Prove that principal value of 1 plus I tan alpha to the power minus I is e to the power alpha times cos log of cos alpha plus I sin log of cos alpha. Now solution. Now we know that e to the power log of fx is equal to fx. Therefore, we write this 1 plus I tan alpha to the power minus I as e to the power log of 1 plus I tan alpha to the power minus I. Now by using logarithmic rule, this is equal to e to the power log of 1 plus I tan alpha to the power minus I. Answer is minus I times log of 1 plus I tan alpha. Now by using principal value formula for this log of 1 plus I tan alpha, so this is equal to e to the power minus I. Now by applying the principal value formula, answer is log of root x square plus y square, but here x be the 1 and y be the tan alpha. The answer is x square means 1 square plus y square means tan square alpha plus I tan inverse y by x. So here y be the tan alpha upon x means 1. Therefore 1 plus I tan alpha to the power minus I is equal to e to the power minus I times, now log of 1 plus tan square of alpha. So 1 plus tan square alpha, answer is sec square alpha, log of root sec square alpha plus I times, now tan inverse tan alpha, answer is alpha. This is equal to e to the power minus I log of, now root sec square alpha, answer is sec alpha plus I times alpha. Now minus I times this bracket, the answer is e to the power minus I log of sec alpha minus I square alpha. Now this is equal to e to the power minus times log sec alpha, answer is log of cos alpha. Now minus I square, now I square be the minus 1, so therefore minus I square be the plus 1 plus alpha. Now this is equal to e to the power I times log of cos alpha times e to the power alpha. Again this is equal to this e to the power alpha as it is, and e to the power I theta, answer is cos theta plus I sin theta. So therefore e to the power I times log cos alpha, answer is cos theta, but here theta be the log of cos alpha, the answer is cos of log cos alpha plus I sin theta, again theta be the log of cos alpha, log of cos alpha. And therefore 1 plus I tan alpha to the power minus I is equal to e to the power alpha times cos of log cos alpha plus I times sin log cos alpha. Hope all of you have understood this problem. In the upcoming lecture, we will solve more problems based on the logarithmic function. Please subscribe the channel and let me know your feedback and comments. Thank you.